Okay, we are live. So last time we were talking about rate of reaction and trying to define it. I'll go through it again for you guys so that you can have the whole picture of your chapter 8 for chemistry. Now let me just see. I hope you guys still remember what we talked about earlier on. Tell me the checkpoint stage 9 science. Okay, what is it like? How many topics do we have for checkpoint stage 9 science? How many topics? Good. 9 topics in total. Then how many do we have for bio? 3. How many topics do we have for chem? 3. How many topics do we have for physics? 3. Good. Making 9, right? Which ones are the bio ones? Which topics are the bio ones? 1 and 4 and 7. You'll be just adding 3. Mr. Vic, which ones are there for chem? 2, 5, 8. Well done. And 8 is the one we are doing right now, which is rate of reaction, right? For chem. What about physics? How many do you have? 3, right? Which ones? Yeah, 3 and what else? 80? Pardon? And 6. And what else? And 9. So 3, 6, and 9. Good. We'll talk about 9. I like 6 a lot as well. So, but right now we are doing the chemistry part. We are doing rate of reaction. So, what chapter are we doing right now, students? Chapter what? Chapter 8, which is a chemistry chapter, right? Out of 9 chapters in total, right? All right, good. Now we are doing the second part here. We are trying to quickly go through the second part of this chapter because it has 2 parts. It has 3 parts. Basically, what you must know is, for you to know this chapter, you must know what is rate and everything. Then you must know 2 things that affect rate, which is first the one we are doing right now, surface area and how it affects rate. Then you need to know temperature and how it affects rate. That's the third part. Are we together? Huh? The first part. I gave you the notes in it. So I'll go through it again for you if you want. In the evening lesson at 5 p.m. Are you gonna be around? Huh? I'll do it. Sorry, your volume is a bit low right now. I can't hear you. Okay, that's still fine. Yeah, that's a good one. So now look at this. Here we're looking at. So I'll make the first one. So make no mistake, the first video is introduction. Okay, this is how you know the whole chapter 8. Victorson, chapter 8 is in 3 parts. Are you hearing me? It's about rates. First one is to make you understand rate of reaction. What does it mean and how to get it? Then the second one is how does surface area affect rate? What is it and how does it affect? Then the third part is about temperature. How does temperature affect rate? If you know this, then you now know how to measure the rate of reaction. Okay, so I'm gonna do the first part with you, and I'm gonna give it to you. Right now, what we are looking at the effect of changing. Basically, we are looking at the second part. You should tell them today we did the second part of chapter 8 in chemistry, which is the effect of changing the surface area on rate of reaction. Are we together? The effect of changing the surface area on the rate of reaction. Okay? So let's see what the effect is going to be. Let's see. Let's go for it, boys. Let's go. Now, surface area, what is it? So this is what I'm going to try and introduce to you, what the word surface area means, and how increasing the surface area of a solid is going to increase the rate. So I can already tell you right now to say, if you are going to have surface area, if you increase it, a lot of people don't know how to increase surface area. If you increase the surface area, then the rate will also increase. Okay, the rate means the speed at which the reaction is happening. Okay, so if the reaction is happening fast, if you are going to increase the surface area, then the reaction will even go faster. Now what we want to know is, how do you increase the surface area? Let me already tell you right now. You make the particles smaller. I want you to know that when you make the particles be dust like this, there is more surface area. Are we together? Okay? You say what? Yes, these ones have more surface area, than the blocks. Okay? Are we together? When you look at all these small particles together, when you bring all of them together, they have a larger surface area than the rocks. Okay? I'm not saying when it's one tiny piece. No, when all of it is brought together. Are you hearing me? All right. So, and when we talk about surface area, we'll be talking about solids. So let's go for it. Let's go for it, boys. Let's go for it. Right. Now, what is it? Let's put the background that I need all of you to have. Here it says, many chemical reactions involve solid reactants. You'll be reacting A and B to give you C and D. So we are looking at a reaction and we want to increase its rate. But this reaction, Victorson and AT, this reaction is having solid reactants. Not gas, but solid. Solid reactants. We take the solid reactants, we put them together, and they are reacting. So we want to see, how can we make this reaction be faster? So here, look at what this says. Have you ever noticed that powdered sugar dissolves faster than a cube? Why is it that sugar is sold in small particles? Why do you think they sell sugar as small particles like this? Because this is better, okay? This increases the surface area. Surface area means how much of the solid is in contact with something else. Look, Victorson, when you have a big rock like this, the surface area is only this part which you can see. You understand? All the part which is inside the rock, we cannot get to it. And that's a big problem. We can't get to it, so the reaction is slow, because only these parts that you can see are the parts that are reacting. But now when it's powder, everything is reacting one time, because everything is in contact, okay? You can get to any piece. You don't have to break anything. For this rock, you have to break the rock to get inside it and access the inside, but not for powder. For powder, you can access anything. So that's why we say it has more surface area, which means more of the rock is available. It's outside. It's exposed. It's about exposure. More of this is exposed. More of the rock is now exposed when you grind it into small pieces. So what do we say, Mr. Victorson? When you grind something, when you make it small, when you combine the surface area of all the small parts, there will be more than the big rocks. Are we together? Are we together, students? Good. So it's a big... Many people don't know how to increase the surface area. They think that making things bigger is better. That's a lie. Surface area, to increase it, you gotta make things smaller. So surface area is one of the most important factors that affects the rate of a reaction. That affects the what? Speed. Rate means the speed of a reaction, right? We want to see, we are only interested in speed of a reaction right now, boys. So surface area is one of the most important factors when you're looking at the speed of a reaction. Okay? Right. So, and this is very important, because when you're doing food production, you're producing cereals and chips and all these, a lot of this food, they are processed, polony and all this. You look at surface area. When you're doing medicine, making medicine, and you're doing mining and many other fields, they master this idea and it helps them to do their processes faster. All right. So here, this is the linear objectives of this chapter. What we need to talk about for us to understand how surface area affects rate. Right now, we have seen that it is one of the most important factors. It's one of the most important factors that affect the speed of a reaction. Surface area affects speed of a reaction. Right. So what we're going to do here, we're going to want to know what surface area is, and then we're going to talk about only why the surface of a solid is the one that reacts. Why is it that the inside of the rock does not react? All right. Then we're going to now see how surface area affects rate of reaction. We've already kind of talked about it, but we're now going to explain it. We'll see it, then we'll explain it using collision theory, because they'll expect you to explain. And when you're explaining in an exam, you have to write like a scientist. You don't just use your common sense. Remember, we said we left common sense a long time ago. We are not interested in common sense. We are interested in the rules. So we are going to see what do the rules say the surface area will do to affect the rate. Then stuff. So now let's go here. Here, look at the big idea. The big idea is this. When you increase the surface area of a solid reactant, when you increase the surface area, we'll see how. But one thing a person must just know, before they know how to increase it, they must just know that when you increase the surface area of a solid reactant, the rate will also increase. Are we together? And here he's telling you it's because of exposure. This is the most important word. The word exposure. Students, the word exposure. You're going to see it when you get to IG. It's still the same word. Exposure, exposure, exposure. This is because more particles are exposed. So you're going to have more successful collisions. Are we together? Are we together, students? What does increasing the surface area do? When you increase the surface area, what will happen to the rate? The rate will also increase. Why? Because more particles are now exposed. Exactly. Don't leave this word. It's the key word, exposed. More particles are exposed, so there will be more successful collisions. That means the rate will then increase. Now let's see what surface area is. Surface area means the total exposed area of a solid. When you look at a solid, how much is it exposed? If you look at big rocks, there is a lot of stuff inside the rock that is not exposed. So the surface area is actually not big. So what does the word surface area mean? What does the word surface area mean, students? The total exposed outside area. Yes, of a solid. We talk about surface area, not of a gas. Of a solid. It's the total exposed area of a solid. Okay? Now, why is this important? Why do we want to know this surface area? Why do we want to know the total exposed area? It is because only the particles that are outside or that are exposed will come in contact with the other reactant for there to be a reaction. Isn't for there to be a reaction, A and B must meet, huh? They must collide, right? Now, if they meet, the more they are exposed, the more they will react. Okay? So if we have more particles of A exposed, that means they'll be meeting B and they'll be reacting. The particles inside the solid cannot react because they are not exposed. They are not in contact with another one until the outer particles have reacted. So the particles on the inside cannot react until the particles on the outside have reacted. So that's a problem. So boys and girls, everybody, Victorson, AT, we need to try and expose. We need to try and expose as much of the solid as we can. Are we together? So when somebody says the word surface area in science, not in maths, but in science, it just means the exposed area. In maths, it's the same thing, but we use formulas. Okay. Why is surface area important? Why do we talk about it? This exposed area. It's because the greater the exposed area, the more the particles are available to react. Are we together? We've already said here, particles in the middle cannot come into contact. So with any other reactant, here they are just giving you an example of solids, a large block of ice like this one. Now, this large block of ice, if you put it into liquid water, can you see that? Now, what will happen? The inside of the ice will remain as an ice. The outside is what will be converting to liquid water, right? Are we together? And this continues to happen until the inside particles are finally exposed. That's when they can dissolve. Victorson, are we together? AT, are we together? Okay, why is surface area important? Why should a person know about surface area? Yes, when you expose more surface area, there will be more particles available to do what? To react at the same time or at that particular time. So can you put this you are going to need to box it up. This you are going to need to box it up. The more the exposed surface area, the more the surface area, the greater the surface area, then we have more particles available to react right now. We want to increase the number of particles that are available to react right now. So we got to expose them. So the greater the exposed surface area, the more the particles are available to react. Are we together? AT, are we together? Why is surface area important? AT? AT, why is surface area important? What does it do? Why is surface area important? Yes, that's important. We said the greater the surface area, the more the particles are available to react right now. That is why surface area is important. This is the statement I want you to respond with. Okay, when I gave you the question, why is surface area important? Because the greater the surface area, the more the solid available to react right now. Are we together? Yes, the more the particles are available to react. We want particles to react more. We want to increase the speed. If you want to increase the speed, then more particles should be reacting right now. You want to increase the speed. You want your reaction to be faster. You want to increase the rate. Then increase the number of particles that are available to react. Because right now, only the particles outside here that are exposed are the ones that are available to react. The particles on the inside cannot. They cannot react until those that are outside have reacted. And that's a problem. We can't wait. So we want to increase the surface area, which is the exposed area of a solid. And how do we do that? Grind the solid. There will be more particles available to react if you do that. Are we together? Great. And so we need to break this big rock down, make it much smaller. Then you're going to have more exposed area, which means larger surface area. Now, when you have a greater exposed surface area, more particles are available to react. Say this. If somebody asks you why surface area is important, it exposes more particles, and they'll be available to react at any given time. Can we continue? Here's an everyday example. Number 1, powdered sugar dissolves faster than sugar cubes. So that is why we use powdered sugar. It is to increase the speed at which it dissolves. Are we together? Good. If you take powdered medicine as sachets, it will dissolve faster than pills, than tablets. All right. And digestion is an everyday example. The reason we break down food is to make it soluble. Large insoluble bits, to make them soluble. When they are small, they then will be having a greater surface area. So don't let anyone lie to you. Grinding to small pieces, you are actually exposing more particles. So you are increasing the surface area. No, you are not decreasing the surface area. You are increasing. Don't let your mind lie to you. That's why we have sawdust burning faster than a log. It's because more of the wood is exposed, so it can react right now. Here. So powder has a largest, this is the explanation to say the reason why you have all this is because powder, when you bring the powder together, it will have more surface area than the rock which made the powder. If you bring all the small ground powder together, they have a larger surface area. So more particles are exposed, okay, to water or whatever, and that means there's a larger surface area. All right. Look at this. Here we have this, which we're going to break down. We have one big block. We break it down. It makes these blocks. Then we keep continuing. It makes powder. Which one has the largest surface area? 1 or 2 or 3? 3. Why? Why does it have a larger surface area, part 3? Because there are many more exposed particles than in the rock in number 1. Okay? Exactly. And if there are many more exposed particles, you will have more collisions, which means you will then have more successful collisions. This, you are now using the collision theory to explain. When you have a larger surface area, you have more exposed particles, more collisions, which will result in more successful collisions. And this will make you have a faster reaction. So the rate will go up because you have a lot of successful collisions. Successful collisions are collisions that result in a reaction. Things can collide and not react. That's not good. We love it when they collide and react. That's what we call a successful collision. And you do it by using small pieces. Large pieces have a smaller surface area. They have fewer exposed particles, fewer collisions, fewer successful collisions, slower rate. Large pieces. Are we together, students? You're not letting me down now. Don't let me down. Don't let me down. Come on now. Large is actually an enemy. You have few exposed particles. That's why it has a smaller surface area. A large piece has fewer exposed particles. A lot of it is inside. So that means, Mr. Man, you may be large, but only a small part is exposed. So your surface area is small. But a tiny pieces, powder, has a larger surface area because pretty much everything is exposed. There are many more exposed particles. Are we together? And when you have more exposed particles, you have more collisions, you have more successful collisions, a faster rate. Are we together? Yes. Here, this is what we're saying. Powder does not contain more particles. No, it doesn't contain more particles, but it has a larger surface area. Are we together? You take a big rock. It has 1 million particles. You grind it into powder. How many particles will you now have? You will still have 1 million, right? If the rock was made up of 1 million, when you grind it into powder, how many particles will you have in your powder? Exactly the same. So grinding into powder, does it increase the number of particles? No. It does not increase the number of... It just does what? What does it do? The key word here. What is the key word here? Yes, it exposes more particles. Okay, more particles are exposed. So make sure you say that. Come on now, students. Let's go. Don't let me down. When you take a big rock, you grind it into powder. You don't have more particles. No, the particles are the same. It's just that in the rock, they were stuck together. Now you have ground them into powder. You have separated them. It's still the same number, but now more are exposed. That's why you can see more particles. They were always there. They were just not exposed. Are we together? So don't say it increases the number of particles. I will run away from you. If you say increasing the, when you grind it into a smaller thing, if you say it increases the number of particles, I'll run away from you. If you say to us that increasing the surface area will increase the number of particles, I'll run away from you. Increasing the surface area is just increasing the number of exposed particles. More particles are exposed, which means they can now collide, and you have more collisions and more successful collisions, and therefore a faster reaction. Okay, you have more collisions, and when you have more collisions, you have more successful collisions, and the reaction becomes faster. Are we together? Don't let me down here. You are not going to let me down. So here they want you to explain it the same way we've just been explaining. And there's this thing that you use to explain. It's called the collision theory. Collision theory says this, boys. Collision theory says that for a reaction to happen, particles must collide. Are we together? Collision theory. For a reaction, let's put it here. Collision theory. Okay, let me put it like this. For a reaction to happen, for a reaction to occur, one, particles must collide. Are we together? Particles must do what? Collide. Can you have a Bluetooth reaction before the particles have collided like here? No. They must first do what? Particles must first do what, class? Particles must collide. And number two, particles must collide with enough energy. Particles should have enough energy for a collision. They must collide with great energy. And number three, it says particles, I don't need to tell you the whole thing, but particles must collide in correct orientation. In the correct orientation. Are we together? Particles must collide in the correct orientation. Are we together, student? Correct orientation, it means, can you wear your shoe the upside down? Like, or face, or the front facing the back? Can you wear your shoe and the front is facing the back? No, you can't. So that means the orientation is wrong. Orientation means the way you are fitting them, okay? They need to be facing each other nicely so that they can fit into each other, okay? Good. So particles must collide, and they must collide with enough energy, and they must collide in the correct orientation. Are we together? Okay. Right. Now we have put this. This is good. Here's what you should know. When you increase the surface area, if this happens, class, then we are going to have a successful collision. Okay? Successful collision is a collision in which Victorson. The particles must have enough energy and they must be in the correct orientation. Okay? So let's see here. So they must collide. So what is an unsuccessful collision? Is one where particles collide, right? But either they don't have enough energy or they may have enough energy but they're in the wrong orientation. Are we together? If the orientation is wrong, will you have a successful collision? If the orientation is wrong, you can't. Yes, good. There will be a collision. Yes, there will be a collision, but not a successful one. For a successful, all three must be met. They must collide, and with correct energy, and in the correct orientation, right? So now, let's see how the collision theory explains the rate of reaction. Now, large pieces have a small surface area, which means fewer are exposed. Large pieces, this is a fact, that large pieces have a small surface area. And that means fewer particles are exposed. Okay? And that means fewer particles can collide. And if there are less collisions, then you will have less successful collisions. Are we together? And the reaction is slow. But powder makes us have a large surface area, which means many more particles are exposed and can collide. Okay? Yes. Many more particles are exposed and collide. The rate of reaction is now increased. Your reaction will be fast. Okay, because you have more successful collisions. Because you have more collisions. So here, smaller pieces, larger surface area. Okay, when you have smaller pieces, you will have a larger surface area. you have more exposed particles. You have more collisions, which means you have more successful collisions and a faster rate of reaction. Have you seen this? Are we sure? Victorson, are you seeing everything here? Okay. So just remember this though. When you increase the surface area, you do not change the amount of product that is being formed. Changing the amount of product, we'll talk about it later, but not now. When you change the surface area, you are changing the rate, the speed. Remember, at your age, you only need to know about the speed. Are we together? The speed. So when we are changing the surface area, we are only making the reaction happen faster. But still, the same amount will be produced, but faster. Are we together? Are we together? Here's a common misconception. Look at this misconception. Look at this. Are you seeing? Okay. Number one, powder makes more gas. Is this true? Can we have more output because of the powder? Can you, let's say you are reacting to get a gas. Can you have more gas because you are now using a powder? That's wrong. Never think that. Surface area changes the products that are formed. Can you get different products because you've changed the surface area? No. So you can't get more, you can't get different. Then the third, can bigger pieces react faster? No, they don't. They have smaller surface area. So number one, all the things you have done, powder just makes the gas be produced more quickly, right? It does not increase the amount of gas that will be produced. Are we together? Right. Now, what does surface area change? Does it change the products? No. It only changes the rate of reaction, right? Good. Changing the surface area only changes the rate. Here, smaller pieces react faster because they have a larger surface area. This is the true version. Are we together? So is this one and this one. Bigger pieces do not react faster. They have a smaller surface area. Smaller pieces react faster. They have a larger surface area. Anyway, I'm going to teach you this practical experiment. We'll do them all in one step. I want to just get to a page here. Don't worry about this. I'll explain. Here, we've skipped an area on graphs. I'll explain to you using some diagrams and I'll make you understand what is going on. But here, whenever you are asked to explain why powder reacts faster, here, larger surface area, more particles are exposed. So there'll be more collisions, which leads to more successful collisions, which leads to a faster rate. Are we together? A faster reaction. Anyone else with a question? Before we do example questions? All right, let's see some example questions. Define surface area. It is obviously the total exposed area of a solid. The total exposed area of a solid. Here, why is it that powdered calcium carbonate reacts faster than marble? It's because the powdered has a larger surface area. Don't forget to say this, okay? Smaller pieces actually have a larger surface area, which means more particles are exposed. So you have more particles available to collide and you have more successful collisions, and this will increase the rate of reaction. Are we together? Here, why must the mass of calcium carbonate remain the same? Okay, when you are changing the surface area, why must you not change mass? You must never change mass to make sure that that only the surface area is going to change, not the amount of particles, right? The surface area only should be changing. So don't change the mass. All right. Here's a summary, which that I want you to remember, and you'll be good. Surface area is one of the most important factors. When a solid is broken into smaller, what we were studying was solids. How we can increase the speed of reactions is between two solids. When a solid is broken into smaller pieces, its surface area increases. And the more particles are exposed, which means there will be more collisions. Anyone with a question? And you have more successful collisions, your reaction will happen faster. Now I'm going to remember, surface area does not change the amount of product. Don't forget this. Changing the surface area does not make us get more. It's a lie that people write. It just makes us get the same stuff, but faster. Brrr. So it just changes how quickly the reaction goes to completion. Okay, this is good. I want to give you some questions on this, and I want to see how you're going to do. Are you ready? Okay. I'm going to give you some questions on this, then I'm going to see how you're going to do. Then we go on to the next thing. Pardon? Yes, I need all of you to write these notes. So I should share the notes, and I need you to write these notes. These are the perfect notes, perfect version of the notes for everything. I've put everything in these notes. So I will need you to write everything that we've gone through in the notes. Are we together? And share it with me. Very neat. This is our important stuff. We need this. That is why I'm putting a lot of effort for you guys. You need to have this to make sure you get the marks. Right, guys? Are we together, 80?